So we move on to the third exercise. So you know now what are rational numbers, what are irrational numbers. We did in the last video how to plot irrational numbers on the number line. So moving further to the third exercise, we have example number 5, that is finding decimal expansions of rational numbers. So we had discussed that every fraction is a rational number. So 10 by 3 is a rational number. 7 by 8 is a rational number, 1 by 7 is a rational number. We have to find the decimal expansion of this. Now, decimal expansion means either the number will terminate. So when I divide 10 by 3, either it's going to terminate or it's going to go forever and forever. It's going to be non-terminating and repeating. So if you look at this example 5, you find that when I divide 10 by 3, 3 3s are 9, then again 10 comes, 3.333, it goes on. So this is 3.3 bar. So this is called non-terminating repeating. If I divide 7 by 8, 8 zeros are here 0 because 7 is smaller here. 8 8s are 64. This is a decimal here, so I'm going to put point. 8 8s are 64, 60, 8 7s are 56, 40, 8 5s are 40. So what I'm getting is 0.875. This is a terminating number. So here we have a non-terminating repeating number. Here we have a terminating number. So the fraction that you are having will either be terminating or non-terminating repeating. Similarly here, 1 upon 7, I'm going to divide this. I'm going to get 7 1s are 7, 30, 7 4s are 28, 20, 7 2s are 14, I get, then 60, 7 8s are 56, then 40 comes, 7 5s are 35. Then what is happening is that after this stage, so I'll just show you that after this stage, the numbers will start repeating. So here they have done up to 7 and stopped there. The reason behind that is that, now see here, 7 7s are 49, then again 1 comes. Now if I put 0 here, again I'm going to get 7 1s are 7. Again I'll get 3 and put 0, 7 4s are 28. So this number will start repeating again. So the value of 1 by 7 is going to be 0.142857 bar, because this 142857 will keep on reoccurring or repeating. So this is how we convert fractions to decimal. So remember, if you're given convert into decimal, either it is going to terminate or it's going to be a non-terminating repeating number. So there is a special technique by which we can understand whether the numbers will terminate or it is going to be non-terminating repeating. That means just see the fraction. It has to be in the lowest form, of course. If there is something cancelling, cancel that. If the denominator you see is made up of factors of 2, 5 or a combination of 2 and 5, then it's going to be terminating. So 3 is not made up of 2s and 5s. This is going to be non-terminating number. So we had a non-terminating repeating number. 8, if you see, is 2 into 2 into 2. It is made up of 2s. The rule says it is made up of 2s. Okay, you can have a combination of 2s, or you can have a combination of 5, or you can have a combination of 5 and 2. Whenever you are having these sort of combinations as the factors of the denominator, then that will be a terminating number. 1 by 7, not made up of 2s and 5s, it's going to be non-terminating repeating. So without actual division, if it's a 1-mark question, you would be able to find out whether the fraction will be terminating or non-terminating repeating. So if I have number 1 by 25, I know it's terminating because this is 5 into 5. Okay, 1 by 10 is going to be terminating, 5 into 2. 1 by 15 is going to be non-terminating because it's made of 5 and 3. And the rule says that denominator should only be made up of 2s, 5s, or a combination of 2 and 5. There shouldn't be any extra number besides these two numbers. So by this technique, we can find out numbers are terminating or non-terminating. And if I want to find the actual value, then by long division, I have to do that. Then we come to the next very, very important thing, that is converting of a number decimal into a fraction. Just now we were doing a fraction into decimal. Right now, this is a decimal value and we want to convert into a fraction. So this is easy, 3.142678. Just see how many digits are there. 1, 2, 3, 4, 5, 6 digits after the decimal. So just put 1 with 6 zeros. And this is going to be a rational number, right? Because what is a rational number? Rational number is anything in the form of P by Q, where Q is not equal to 0. So I can easily convert. Let's say if I want to convert 3.1 into a fraction, this will be 31 by 10. If I want to do 1.57 as a fraction, This will be 157 by 100. So just see how many numbers are there after the decimal, and accordingly we put the number of zeros there, 10, 100 and so on. The next question is very, very important. Now, if you see, this is not 0.3, it is 0.3 bar. How to convert 0.3 bar? Now, if I am having a number 0.3, that is easy, this is 3 by 10. But when I am having 0.3, it is not 3 by 10 because 3 by 10 is coming 0.3. 0.3 bar means when I am dividing one number by the other, the fraction is going to come 1 by 3 will come 0.333, right? So we need to find out that the equivalent fraction of this such that when I divide one number by the other, I'll get 0.3333 recurring. So if it's a single number, it's very easy. Suppose I want to convert 0.3 bar. What I need to do is instead of dividing by 10, just divide by 9, right? So 3 by 9 will become 1 by 3. That's the answer. I want to convert 0.45 bar in terms of a rational number or in terms of P by Q. Then how will I do it? Then it's going to be 45 by, don't put 100 because there's a bar here. We're going to put it as 45 by 99. Of course, you'll have to cancel by 3 here. So we get 15 by 33. Again, cancel by 3. You are going to get 5 upon 11. Now, if I divide 5 by 11, I'm going to get 0.45 bar. Let's check this. See, 5 by 11, 0. I'm going to divide this, so I'll get 4s are 44. I'm going to get 60. 11 5s are 55. I'm going to get 50 here. 11 4s are 44. Again, I'll get 50. So here I will get here 4 5 4 5. I'm going to get repeated here, right? So 50 here, 44 here. So 60, 11 5s are 55. And this process will go on. So I'll get 0.45 bar. So this is the easiest way to do any bar question. When the number has have a bar, just divide by 9. But remember, this only works if the bar is on the whole digit after the decimal point. So I'm going to just explain that also. So 0.3 bar, you understood, the answer is 1 by 3. 1.27 bar, again, the simple technique, 1.27 bar. Now here I find that the number is, the decimal is on 2 and 7 both, right? So if I'm having these sort of numbers, then what has to be done? So the technique is very simple, as they have explained now here, 1.27 bar. So 1.27 bar, what we'll do is assume this as X. Assume this as X, 1.27 bar, assume it as X. Now what we are going to do, see how many numbers are there in the bar. There are 2 numbers here, so I'm going to multiply both sides by 100. Why 100? Because there are 2 numbers. If there is only one number, you can multiply by 10, right? So we are going to multiply by 100. When I'm going to multiply by 100, the decimal shifts 2 places to the right. So I'm having 1.272727. I'm going to shift here. What will happen? It will become 127.2727. The 27 will remain, right? That's not going to disappear. So when I'm going to multiply this, I'll get 127.27 bar. And when I'm going to multiply the RHS, that's going to be 100x. So I'm getting 2 numbers here. One is 1.27 bar is x and 127.27 bar is 100x. What you need to do is subtract this now. Subtract the smaller from the bigger. So subtract 1 from 2. So I'm going to subtract 127 minus 0.27 bar minus 1.27 bar. And here I'm going to get 100x minus x. Now when I'm going to subtract this, I'm going to get 126 because this is going to be 0, 0, 27 bar and 27 bar and 27 bar. 127 minus 1, we get 126. 100x minus x, we get 99x. So x value is going to be 126 by 99. X value will come 126 by 99. So this I can cancel by 3. So this is going to be 43 by 33. So this is the method by which we can convert any number here by convert into a lower fraction. Now see here. So I've got 126 by, so this is going to be 42 here. Okay, 42 by 33. Now 42 by 33, I can solve further. I can cancel this by 3 again. So this is 314 and 311. So what am I going to get? I'm going to get the same answer, 14 upon 11. So this method is used when we are having numbers like this 1.27 bar, 3.45 bar, etc. So this is an important question where we can convert the bar into a fraction. Now here this is another very important question, that is 0.2353535. The 2 is not repeating, the 35 is repeating. So that is 0.235 and 35 is repeating. So that is why they are written 0.235 bar. Now we have to convert this in the form of a fraction p by q. So here what we need to do is that first we have to bring the decimal after the 2. So what am I going to do? Step number 1, 0.235 bar. This is my x value. Okay, the original question is x. What am I going to do? I'm just going to multiply by 10 and bring the decimal before the bar. So what will happen? This will become 2.35 bar is 10x. Now the same procedure as we did just now. Multiply this by 100. I'm going to multiply both these by 100. So I'm going to get 235.35 bar. Because when I multiply by 100, decimal will shift 2 places to the right. And 100 into 10 is going to give me 1000x. Right? Why am I multiplying by 100? Because there are 2 numbers here. When there are 2 numbers in the after the decimal, you're going to multiply that by 100. Now the same procedure, you're going to subtract this. So I'm going to subtract the smaller from the bigger. So subtract this, I'm going to get 35 bar 0. This is going to become 233. And here I'm going to subtract 1010. So I'm going to get 990x. So value x will be 233 by 990, right? So I'm going to get this value 233 by 990. So this method you need to practice because this is very likely to come in the exam because this is important, how to convert into a fraction when there is numbers which are recurring. So based on this, you have, of course, pi is the most famous example of an irrational number given by one of the greatest mathematicians and scientists, the Greek genius Archimedes. He was the first to compute the digits of pi. He showed that the value of pi is approximately somewhere between 3.140845 and 3.142857, right? And this was more than 2,500 years back. So this is what is irrational numbers and how we convert that into p by q form. Now, if I want to find an irrational number between 1 by 7 and 2 by 7, if I want to find an irrational number between 1 by 7 and 2 by 7, then the value of 1 by 7 when I divide, we'll get 0.142857 bar, right? When we divide 1 by 7, long division, we'll get this. Now, how do you find 2 by 7? Again, divide 2 by 7, you will get 0.28571 bar. Now, we want an irrational number between this. Irrational numbers are numbers which are non-terminating and non-repeating. So you want a number somewhere between 0.1428 and between 0.2857. So something between this. So I can choose any series. Here they have chosen a series 1, 5. And then what you need to do is don't write 1, 5, 1, 5 because that becomes repeating. So you have to change the series. So 1, 5, 1, 5, 5, 1, 5, 5, put 3 dots. That means this process goes on. I can do a series with 0.16, 166, 166, and 3 dots indicating this goes on. I can do this series up to less than 0.28. That means I can go on repeating this up to 0.27. So you can have so many possibilities, 0.27, 277, 277, and so on, right? So any series you can do between 0.14 and 0.28. That means from 0.15 onwards to 0.27, you can put any series there. So this is how we write examples of irrational numbers between two numbers. So based on this, what we have done is the exercise 1.3. So the first question here, write the following in decimal form. So what you need to do is get 36 by 100 in decimal form. Now this is easy because division by 100, you just have to shift the decimal to the left. So 0.36. So what kind of decimal expansion is this? Is a terminating number. This is a terminating number. We go to 1 by 11. When I try to divide 1 by 11, let's see what's going to happen. So when I'm going to divide 1 by 11, 11, 0. Here again 0, 11 nines are 99. Subtract this, I get 0. 10 is smaller than 11, so I'm going to put 0 here. 100, 11 nines are 99. So what happens is that I observe that the 0, 9 is repeating. So as I had informed earlier that whenever we are having a fraction, either it's going to be a terminating number or it's going to be non-terminating repeating. Don't stop until the numbers repeat or terminates. So the first one we saw, it was a terminating number. The second one will be non-terminating, but it's going to repeat, right? So this is how we have to do this question. So you can try like this, the third one. So the third one is 4 1 by 8. This is a mixed fraction. So this is 1 by 11. This is non-terminating and repeating. Okay, that's non-terminating and repeating. Third one is a mixed fraction. If you are getting any mixed fraction, please remember that you need to convert this into a proper fraction. So how do you convert into proper fraction? That is 4 1 by 8, you will multiply 8 for the 32 plus 1, 33 by 8, right? You are going to multiply 8 and 4. And after multiplying 8 and 4, then what happens is that you will add that 1 there. So 8 4 is 32, 32 plus 1, 33. So 33 divided by 8. Now one technique that we had done was what? When we divide 33 by 8, the denominator is 8. So denominator is made up of 2's. So when the denominator is made up of 2's, then what's going to happen is that it's going to be terminating. So let's verify that. 33 by 8, 8 4s are 32, 1 0, 8 1s are 8, 20, 8 2s are 16, 40, 8 5s are 40. So what's going to happen? This is going to be 4.125. So I'm going to get a terminating number. Now another clue that I can give you is that how do I know that this is going to terminate? I told you if the denominator is made up of 2's or 5's or a combination of 2 and 5, it's going to terminate. Also, 8 is 2 cubed and the power of 2 is 3. So this indicates that this decimal expansion will end after 3 digits. So that's also an important clue to understand that when you solve any question, we should know after how many places is it going to terminate, right? Then we go to the next one, that is 3 by 13. Now, when I'm going to divide 3 by 13, the denominator 13 is neither a factor of 2 nor of 5. So it's going to be obviously again non-terminating repeating. So I'm going to divide 3 by 13. So what will happen? 0.2's are 26. I'm going to get 40. 13 3's are 39. I'm going to get 1 and put 0 here. Now 10 is smaller than 13. I'm going to put 0 here. So that's not going to come there. So again, I'll put 0, 100. Now 13 goes, how many times? 13 goes 7 times. And I'm going to get 13 7s are 91. And 90 I will get now here. So 7s are 91. So obviously it will not go. 13 6 will go. 13 6 are 78. So here I'm going to subtract this. I'll get 120. Then when I get 120, again, when I try this, I'm going to get 13 9s are 117. Now again, I'll get 30. 30 when I'll get 13 2s are 26. So at this point, what will happen now? This number will start repeating 2 3 0 7 6 9. So 3 by 13 will be 0.230769. Now, if you notice, I didn't stop the division till I got the repeating series. So you cannot do 0.23 and relax. Okay, you have to keep doing it till you get the repeating series. So 3 by 13 will be 0.230769 bar. Okay, so this is what kind of decimal expansion? It's going to be a non-terminating repeating number. Next one, 2 by 11. This is slightly simple. 2 by 11, 0.11 1s are 11, 90, 11 8s are 88. Now I'm getting 20, 11 1. So 0.18. So 2 by 11 will be 0.18 recurring. That is 0.18 bar. So what type of decimal expansion is it? It's going to be a non-terminating repeating number. Okay, so 2 by 11 is non-terminating repeating decimal expansion. Then the last part we have 329 by 400. Now when I'm going to divide 329 by 400, let's see what happens. 0 point, I'll put a 0 here. So 8s are 32. So 3200 I'll get. When I subtract this, I will get 90, put a 0. So 400 goes 2 times, that is 800. When I subtract, I'm going to get 100, I'll put a 0. Again, 400 2s are 800. Again, I'll subtract, I'll get 200. So I'm going to put a 0, 2000, and I'll get 4. 5s are 20. So 400 into 5, I'm getting 2000. This is answer 0.8225. So this is a simple process of division. But remember, do not stop unless it terminates or it is non-terminating and it starts repeating. So some of the questions here you found that it's repeating and some are terminating. Now question number 2, you know that the value of 1 by 7 is 0.142857 bar. Can you predict the value of 2 by 7, 3 by 7 and so on without actually dividing? So without division we have to do this. Now most of the books are giving us a technique, and I'm going to show you a different technique that how we can predict the values of the other. So question is 1 by 7 is 0.142857. Okay, the value of 1 by 7 is already given to us. Can you predict the value of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7? This is the question. Now many of the books that I have seen are doing like this. They have said don't use division. So what they are doing is multiplying. So 2 into 1 by 7. So what are they doing? They are multiplying 0.142857 and multiplying by 2 and getting the answer. And this they are multiplying 1 by 7 value with 3. This they are multiplying 1 by 7 with 4 and so on. But I'm going to teach you a different technique, which is actually prediction. You neither have to divide nor you have to multiply, right? So what is that? What you need to do is understand that when there is a repeating series like this, 142857. Now, in terms of value, after 1, the next number is 2. So your next answer will be starting from 2. So this answer will be 0.2857. Then go back here 14. So I'm not changing the series. The series is as it is. Only the value is changing. This was starting with 1. The next answer 2 by 7 will start with 2, right? 3 by 7, again prediction. After 2, the number is 3, but there is no 3 here. So skip 3. The next number after 3 is 4 in terms of value. So the next answer will start with 4. So I'm going to start my answer 0. This will be 4, 2, 8, 5, 7 and 1. And I'm going to put a bar. So value of 3 by 7 is this. So you can multiply 3 with 1 by 7, you will get the same answer. And you can also check. So 4 by 7. Now after 4, in terms of value, the next number is 5. So my next answer will start with 5. So this will be 0.571. Come back here 4 to 8. And I'm going to get 0.571428. After 5, there is 6, but there is no 6 in the series. So I'm going to start with 7, 0. I will have 7, 1, 4, 2, 8. Come back here 5. The last one, after 7 will come 8. So my answer will be 0. Start with 8, 8, 5, 7, 1, 4, 2. So this is called the prediction method. We have neither multiplied nor have we divided. Okay. So this is a very important method by which we can easily find out all the values. Okay, so we've got question number 2. Now question number 3, expressing the following in the form of P by Q. So 0.6 bar, the first question is 0.6 bar. So 0.6 bar is easy. I told you when there is 0 point something, easy method is just divide by 9. Okay, 0.6 is 6 by 10. But when I am having 0.6 bar, the easiest method is divide by 9. So 0.6 bar we will write as 6 by 9. What is 6 by 9? Cancel by 3. I'm going to get 2 by 3. So the answer to 0.6 bar is 2 by 3. If you have 0.47 bar, now I'm going to 0.47 bar. Okay, how will I convert 0.47 bar? Now, if you notice the question here, the bar is only on the 7, not on the 4. If it was 0.47 bar, it would have been easy. 47, the full, it would have been bar, then the answer would have been 47 by 99, right? But it is 0.4 and there is bar only on this. So how to do this? So this I am explaining. 0.47 bar, assume it as x. I told you that when the decimal is not in front of the bar, you will have to bring it there. So what am I going to do? I'm going to multiply this whole thing by 10. I'm going to multiply LHS with 10. I'm going to multiply the RHS with 10. So when I multiply by 10, I'm going to get 4.7 bar because the decimal will shift one place to the right. Equal to, multiply this by 10, we get 10x. So this is my first equation. My first equation should always be having the bar and the decimal with no distance. That means the decimal and bar should be together, not like this. Then you see how many numbers are there in the bar. There is only one number. So I'm going to multiply this by 10. When I multiply by 10, decimal will shift one place to the right. So 4.7 bar means what? 4.777 recurring. So when I multiply by 10, the decimal is going to shift one place to the right. So this is going to be 47.7 bar. 10 into 10, you are going to get 100. So I'm going to get 47.7 bar is 100x. Now, as I explained when I was doing the solved examples, you will subtract this. So 47.7 bar minus 4.7 bar is equal to 100x minus 10x. So what is going to happen? This is going to be 43.0 is equal to 90x. So what is going to happen? Your answer of x will be 43 upon 90. Right? So you can note down this, how to calculate 0.47 bar in the form of a fraction. How to calculate 0.47 bar in the form of fraction, right? The next one is 0.001. This is simple because now all the numbers are there in the bar. So this answer is going to be 1 upon 999. The answer of 0.001 is going to be 1 upon 999. Question number 4. Express 0.9999 in the form of P by Q. 0.999 recurring can be written as 0.9 bar and 0.9 bar can be written as 9 upon 9, which is equal to 1. So actually 0.9999 recurring is actually 1. And here that is why they have given us a question in this, that are you surprised by the answer? Are you surprised by the answer? Because why is 0.9 bar coming 1? The reason is very simple. The reason is that when you are having 0.9999 continuously infinite, then what is happening? The difference between that and 1 is very, very minute. Okay, it cannot be accounted for. It's very, very minute. And that is why we are saying that 0.9 bar. So it is like 99 rupees and 99,999, it goes on. Then what happens is that when we are having a number 99.9999 recurring to millions of decimals, that is almost equal to 100, because the difference between this and 100 will be 0.00000 infinity, some 1. So that is hardly anything. That is why there is hardly any difference between 0.9 bar and 1, and that is why we are getting this answer. Now, question number 5 is a slightly long question. That is, what can be the maximum number of digits in the repeating block when we divide 1 by 17? So division of 1 by 17. I'm just going to show you. You have to try it out yourself. So when I'm dividing 1 by 17, what is going to happen? They are asking us to divide 1 by 17 and find out what will happen. How many numbers, after how many numbers will the repetition start? So you see 1 is smaller than 17, so I'm going to put 0 here. Again, 10 is smaller, so I'm going to put 0 here. Then I'm going to put 100, so this is going to be 17, 5s are 85. So first step, I'm getting 17, 5s are 85. Now I'm going to subtract this, I'll get 150. So then I'm going to multiply 17 goes 8 times, I'll get 136. Then I'm going to subtract here, I'll get 14, bring 0, 140. 140 means again I can do 8. So 8s are 136 again. So I'm going to get 40, 17 2s are 34. Now we get 60 here, 6, and I'm bringing down the 0. 17 3s are 51. Then I'll get 9, put a 0. 17 5s are 85. I'm going to subtract this, I'll get 5, and then I'm going to bring down 0, 50. See, I'm not supposed to stop till the repetition comes, okay? So I'm getting 50 here. Now, how many times does it go? 17 3s are 51, it is low, so 17 2 only. So 17 2s are 34. So here I'll get 16, and I'm going to get 160 here. So then the next number, I've got 0.588235. And now how many times will it go? 9 times. So when I multiply by 9, 17 into 9, I'm going to get 153. Then I'm going to subtract this. I'm going to get 70. So this is 17 4s are 68. You see how long it's getting. So when I subtract this, I'm getting now 20. So 17 1s are 17. Then I'm going to subtract this. I'll get 3, put down a 0. I'll get 30. Again, 17 1s are 17. So here again, I'll subtract. I'm going to get 13. Now, if I get 30 and 17 I've got here, I'll get 130. If it is 130, then how many times will it go? It will go 7 times. 119. So I'm just continuing from here because there's no space here. You may not be able to see. So I've got 130. I've got 7 times 119. So I'm subtracting this. I'm going to get 130 and 119, right? So I'm going to get here 11. I'm going to bring down the 0, 110. So 17 6 are 102. 17 6 are 102. So you will get now subtract 8, bring down 0, 80. 17 4s are 68. And then you will subtract this, you will get 120. And now if I multiply by 7, I will get 119. And now I'm getting 1. I'll bring down 0. So now 0, this process starts repeating now. 0, 0, 5, like this. 7. After 7, the repetition will start. So how many decimals is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the value of 1 by 17 is 0.05888235294117647 recurring. Okay, that will be the final answer. After this, the repetition will start. So how many, the question was after how many places will the repeating block start? The answer will be, it will repeat after 16 digits or 16 decimal points. So after every 16, what is going to happen? The same series is going to continue. Then we have question number 6. Look at several examples of rational numbers. This I had already told you that how can you find out from the value of P by Q that which will have terminating. So all fractions where the denominator is having factors of 2 or 5. Okay, it is either 2 or 5. Q should be in the form of 2s or 5s or a combination of 2 and 5. So what is the property that Q must have? Q must have a property that it should be factors of 2, 5 or a combination of 2 and 5. Or Q should be in the form of 2 to the power m into 5 to the power n, where m and n are whole numbers. Okay, it can be any whole number. Why whole number? Because it can be 0 also. So if it is 0, then 2 doesn't exist. If n is 0, 5 doesn't exist. So it can be only 2, only 5, or a combination of 2s and 5s. So that's the property. Question number 7, write 3 numbers whose decimal expansions are non-terminating and non-recurring. 3 numbers which are non-terminating and non-recurring. So any number, they are not specified which. So it can be any number. So 1.10, 100, 100, 100. This can be an example. of non-terminating and non-recurring. I'm not writing 1010 right there. Okay. So this can be example, any example you can write 7.23, 233, 233, dash, 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 8.68, 688, 6888, dash, dash, dash. So this is a series which is non-terminating and non-repeating. Please remember to put 3 dashes, which shows that it is non-terminating, and make a series like this, any 3. They have not specified between or anything, so you can write any 3 numbers. Then find 3 different irrational numbers between 5/7 and 9/11. So this is specified that it has to be between this. So when I divide 5/7, what am I going to get? 0.7749, about 0.71 something. And when I divide 9/11, see what is happening. So 11 8s are 88, 11 1s are 11. So I'm going to get 0.81 something. So between 0.71 and 0.81, I need 3 numbers, 3 irrational numbers. So irrational numbers means it has to be non-terminating and non-repeating. So between 0.71 and 0.81, you can write down any series. So it could be a 0.72 series, 72, 722, 7222. It could be a 73 series, 74 series, anything. 75 series, 75, 755, 7555, and so on. I can have any series up to 0.80, 0.80, 800, 8000, dash, dash, dash. So these are all irrational numbers between 0.71 and 0.81. That means between 5/7 and 9/11. These are only approximate values, of course, but that is enough to find out this answer. Then the last question of the exercise, classify the following as rational or irrational. Root 23 is an irrational number, because if I try to find out the root of 23, it will come non-terminating, non-repeating. It will go on and on, no end. Root 225 is a rational number. Now, why is it rational? Because root 225 is 15. It's a perfect number. It's a perfect square. 15 square is 225. If you do not know, then find out the prime factorization. Okay. If I'm going to find the prime factorization, what will I get? 5, 45, 5 goes 9 times, 3, 3, and 3. So if it's a perfect square, what happens? I can make groups of 2. So root 225 can be written as 5 into 3, that is 15. So if you know already, it's cool, it's easy, that root 225 is 15, it's rational. If you don't know whether it's a perfect square or not, you can do the prime factorization method, which you did in class 8, make groups of 2. If all the numbers are getting in groups of 2, that means it's a perfect square. So the root will no longer be there, the root will come out. So root 225 is 15, which is rational. 0.3796, this is a terminating number, right? It's a terminating number. All terminating numbers are rational. The 0.3796, it has stopped. When it is stopped, then that is called terminating number. All terminating numbers are rational. So third part is rational. 7.478, 478, if you see the numbers are recurring, and there are 3 dots indicating it is repeating. So all repeating numbers are also rational. So this is a rational number, because we know that all terminating numbers, this is terminating number, all terminating numbers are rational, all repeating numbers are also rational. And what about 1.10, 100, 100, what is happening here? Non-terminating and non-repeating. Non-terminating, non-repeating. It's not 10, series. Unlike here, no, so numbers are not repeating in a particular order. 10, then there is 100, 100, it's non-repeating. There is no specific order here of the same numbers repeating in the same pattern, right? That is called repeating. This is non-terminating, 3 dots are there, and non-repeating. Therefore, this is an irrational number, right? So this is our third exercise. In the next video, I will be explaining to you the fourth exercise.